Most of the 5 classes.
Hello everyone, good morning. Do you have any question before we start? Any question? Yes.
I forgot, in the homework, it showed the 6 different scatter plots and it had different wording for it. I forgot what the wording were. It was like not equal.
So you should, for that question, you should look for like correlation to see what kind of correlation matches that plot.
Okay. So the correlation will match the wording.
Match the plot, match the scatter plot. Like if the relation is a strong correlation, should be a number close to -1 or 1, okay? And then if the direction of a scatter plot is positively associated, correlation is positive, otherwise negative, okay? If there is not relation at all, correlation is 0.
Okay. So she's using a different wording.
Yes. You should see what correlation matches that graph and that.
So if you test us on it, you're not going to use the other wording, you're going to use the correlation.
Correlation.
Okay.
Yes. Yeah, if there is that 6 plots, it will be correlation. You should assign different correlation to each plot. Any other question? No? Okay, so chapter 5. Today we are going to talk about that imaginary line we are passing through all the points. So let's talk about linear form, because I told you we are going to concentrate on linear form. So if you have a linear form, means there is a straight line passing through all the points, okay? This straight line has equation, has a formula, and then most of you should know the equation of a straight line. We have a slope, we have y-intercept, correct? So what is the slope intercept formula? Do you remember? Huh? Y equals mx plus b, correct? And this one was a slope, this one was y-intercept, right? So in math, you learned this, right? You know the number here is a coefficient of x, and whatever number you have here as a coefficient of x is a slope. So now let's say I change the m and b and write it down like bx plus a. So what you will say? B is still b is the slope, right? And a will be the y-intercept. So unfortunately in this book we are going to see this kind of formula. So we will have a and b in this form. So b will be the slope and a will be the y-intercept. Okay? So now the line passing through all this point is a straight line, and it should have this kind of formula, this kind of equation. So we call this line a regression line. Regression line. So regression line is the straight line passing through all the points in a scatter plot. And whenever this line passing through all the points, and the distance from each point to that line is as small as possible, means this line is fitting all the points perfectly. So the distance of line to each point is as small as possible. Means we are minimizing the distance. So later you will see what are these distances. So now this new line that I said fits all the points perfectly. is the least square regression line. So there's a new name for that. It's a regression line, but as long as it has the best fit and the distance from each point to the line is as small as possible, we call that least square regression line. Formula for least square regression line is y hat. Look at this, I said hat. So y hat equal to a slope multiply x plus a. So now you know b is a slope here, a is y-intercept, correct? This y hat, we know that y itself was response variable, right? And then x was explanatory variable. Right? So what is this y hat now? So when I was explaining explanatory variable and response variable, I was talking about the response variable is the predicted variable, correct? And then explanatory variable was a predictor, right? I said if I have as much as information I need, I'm able to predict your exam score in future, right? Your exam score was the response variable. So the response variable was the original exam score I get from your first exam, right? And the second exam score that I'm going to predict will be different response variable, correct? Will be the predicted response variable, correct? And now this predicted response variable is y hat. So y hat is the predicted response variable. So y hat is predicted response variable. So let's write down here the response variable. I said these are the original response variable that you received. I mean, I received from your first exam. And let's call this observed y, or observed response. And now you know these are the original data I get. And then later, using all this information, I'm able to predict your exams. Okay? For us, finding the equation for a line is important. As long as we have all the exam scores and all the study times, like all the response variable, observed response variable, and all the explanatory variables, I'm able to draw a line. I'm able to write the equation for line. How? I mean, math, we did that. We had some points, and then we find a slope, right? And then after we find a slope, we find a y-intercept, and then replace everything here, and we will write equation for a line, right? In Math 120, you should learn that, how to draw equation for a line using this information. So drawing a line, writing equation for a line should not be that difficult. So obviously, if there are too many data, it will be difficult, and we are not going to do that with hand. We should use computer software, okay? And then obviously, computer can fit the best line, least square regression line, okay? So this is a computer's responsibility. But still, we can have the formula for example, a slope, formula for y-intercept, when we have huge data set. So now the formula for a slope, let's write down, here is the slope, B. Formula for a slope is R, what was R?
Correlation.
Correlation, correct? So to find a slope, we should have correlation of, means relation between two variables, correct? And then, what was SY? Of Y, correct? Standard deviation of Y, right? And divide by S of X, standard deviation of X. So as long as we have a standard deviation of response variable, a standard deviation of explanatory variable, we are able to, and also correlation between two variables, we are able to find the slope of line. And then now, we get the slope, we can find the intercept, which is A. Y bar minus B X bar. What was Y bar? Mean of Y, correct? And X bar is mean of X. And B is coming from the previous step, right? Slope. So when we have a slope and A intercept as a number, we can replace it in, actually, this should have height now. We can replace it here and here, and we will have a line like this. Y hat equal to, let's say, a number, X plus another number. Something like this. And this will be the equation of least square regression line for this relation between X and Y. So this is one of the things we can do in this chapter. We can talk about this least square regression line, a slope, intercept, all of this. And then the other thing we can talk about in this chapter is how to find the predicted Y. How to find the predicted exam score, for example. How? So it will be so easy. If you have an equation of line like that, Y hat equal 1/3x plus 2. So let's say this is a least square regression line for exam score and the study time. If I have the study time, some numbers, right? I can replace it here, okay? What I get? Predicted exam score. That easy. So for any explanatory variable, study time, I can get a predicted exam score. So my student will tell me next time, I studied 5 hours, and I already had this least square regression line from your first exam and first study time. So the next time when you tell me I studied 5 hours, I will say, okay, I put this 5 hours here, I will get a predicted exam score for that 5 hours. And I can predict, so your second exam score will be this. So this is the second thing we can learn in this chapter, how to find predicted response variable. And then the next thing in this chapter we will see is the residual or error. So now we will look at the least square regression line and talk about least square regression line more in detail. Let's say we have 3 individuals in this study, in this scatter plot. 1, 2, 3. Okay? And the line you see, vertical line, to this least square regression line are the distance that I was talking about. Distance from each point to the line. I said least square regression line, make these distances as small as possible. Correct? So if we want to have the best fit for our relation, these distances here, this one should be as small as possible. Like you should imagine this least square regression line is passing through each line and will have the same, like it will not favor any specific point. It will pass through all of them and makes the distance, average distance of all of them as small as possible. Not, be close to one of these points and far from other point. No, it will make all the distances as small as possible. And obviously computer can do that, correct? So now these distances are error or residual in a study. Why? Because imagine, for example, this point here will have x variable, correct? X coordinate will have y coordinate, correct? So what are these x and y? These are the first data I get from, individual. Means the y you see here is observed y, because this is the original y response variable I got. And according to this x and y, I was able to put this point here, for example. So now, what this least square regression line exactly tells us? It tells us, because the equation of line is y hat equals blah blah, right? So it tells us, for this point, yes, you have x and y, but you will have a predicted y, which is exactly on this point. So when I say predicted y, exactly on this point, I mean just draw an imaginary line, you will see a predicted y. So for this individual, we had x, we had observed y, and then according to this least square regression line, now you can see a y hat or predicted y. So not just for one point, for all of this point, we have these three information. If we have least square regression line, we have x, y, and predicted y. Okay? So now the distance will be the difference between predicted y and the original y. So imagine like that. I tell you, because of the information I got, I will tell you your exam score should be 90% according to whatever you told me. And then all of a sudden you get 80%. The real number is 80. So there's a difference between these two, predicted y and the observed y now. So what we call this is error, right? This is the difference, which I didn't, expect that difference. Because I thought according to information, your score should be 90, but now I see that your score is 80. So there is this much 10% difference. And for each individual, maybe this happens. But sometimes maybe it doesn't happen at all. How? The point will be exactly on the line. What that means observed y is exactly equal to predicted y. Because I said for each point the predicted y will be on the line, right? So if a point is on the line, means it had exact same as what I predicted, right? The exact observed response as I predicted. So this is kind of explanation about this least square regression line and what exactly it tells us. And then now the difference I'm talking about, we call that residual or error. So what is residual now? Is the difference between the observed y and predicted y. So y minus y hat observed minus predicted. So now you understand that this is the difference of the point we see on the scatter plot to the least square regression line, correct? So what happens if the error means the difference is positive? What happens if the difference is negative? So the only thing I can talk about in this class is this. If the difference between observed and predicted y is positive, the point would be somewhere on this side of least square regression line, on above the least square regression line. Okay, let me tell you why. Because let's say this one is the observed y, correct? 4.2, and here you would have predicted y, correct? So let me write down. Observed y was 4.2, for example. What was the predicted y? From here, imaginary line, to here. What is that? 3.8, right? Correct? The point is above the line. So what I'm going to do, I'm going to find the residual. So observed y minus predicted y. So the residual is positive, right? And as I said, if you see a positive residual, means the point is above the line. And then if you do the same thing for this one, the residual should be a negative number, correct? So be careful always. This one comes first and this one is second. Changing the order will give us wrong information, correct? Do you have any questions so far? I try my best to, put everything, formula, explain everything for you at once, and then I will show you 2 questions, and then we'll use all this information to see if you understand the question and you are able to solve a question. Okay? So we talked about residual. Do you have any question about this? Okay. So now I want to explain the slope of line more. The slope of line was b, right? I think in this class most of the students have a good math background, so you should be able to understand this better. So I want to start with a kind of trial and put some number in the line, and then after observing what's happening, I will explain the slope. So the process I'm going to do has this kind of conclusion, interpreting a slope. Okay? So let's say we have this square regression line, okay? B is a slope, A is intercept, right? Tell me, for x equal y, what will be the y hat? I mean, keep the B and A, tell me like this. B multiply some number plus A. Just you're replacing 1 in this formula. So what y hat will be? B, times 1 plus A. That's it, correct? So you even can ignore 1, yes, because B multiply 1 is just B, correct? So we have B plus A. So now let's increase X 1 unit. So I'm increasing the explanatory variable 1 unit. Y hat is equal to 2B plus A. Correct. 1 more unit. Y hat is plus A. So if I keep increasing X to X equal N, we have Y hat equal to MB, B, MB plus A, correct? So I hope you see the change here. We increase explanatory variable just 1 unit every step, and Y hat will increase how much unit? there is an increase in by half, right? How much unit? One unit? Means it's adding 1 here? No, it's not. What is that? How much unit? Tell me.
I said it was
Double? So, okay. B plus A, B plus B plus A, B plus B plus B plus A. So now can you tell me what is increasing? How y hat is increasing? B units, right? Is that correct? So we are increasing x 1 unit, y hat increasing b units, right? Now what is b? B is slope, correct? So this is the definition of a slope. For 1 unit increase in explanatory variables, predicted response will increase slope unit, correct? So this is the definition of the slope. So I will write down. Interpreting the slope. For 1 unit increase in explanatory variable, x, predicted response, we call that by half, right? Will increase, actually it can decrease too, and I will show you how. Increase or decrease B units. So you said increase because the B was a plus number. And you are imagining B as a positive number, right? For example, if B was 2, it's increasing 2 over and over. It's increasing, right? So what would happen if your slope was negative 2? Decreasing, right? Each step you have negative 2, negative 2, negative 2 means it's decreasing. So increase or decreasing depends on the sign of a slope. So we say increase when a slope is positive. We say decrease when a slope is negative. Okay? Do you have any question? So let's see the example. Okay? Okay, so let's start with this one. The least squares regression line to predict a student's STAT 1.5 test score from 0 to 100 from the number of hours studied was determined from a class of 55 STAT 1.5 students. And this is the least square regression line. Formula for least square regression line for this relation, correct? So what is the slope in this line?
2.7.
Right? Is that correct?
Yes.
The slope is the coefficient of x, correct? So this is B. What is y-intercept?
46.2.
Exactly. It says one student in the class studies for 16 hours and scored 87 on the exam. Do you remember I told you for chapter 4 and 5, before solving any question, you should know what variable is Response. What variable is explanatory? So this is the easiest actually example because we talked about this study time and exam score over and over and over. So what is the response variable? Exam score, right? So the number you get, 87 here, where is that? For that student will be observed by, right? This is a response. So you will write down as soon as you know which variable is response, which variable is explanatory, you know the exam score is response variable. So the number you're observing will be the observed y. You will write down y is equal to 80. What was that? 7. And then, what is the other number? What should I write down? X equals 16, correct? So now, instead of that x here in this line, put 16, what you will get? What you will get? Y hat, correct? So what is y hat? Predicted what? Predicted exam score, correct? So you will find predicted exam score for this student who studied 16 hours, right? So what you did, first of all, you found response variable, observed response, then explanatory variable, correct? And then just use the line, replace the number you got x, and then you will get y hat, which is the predicted response, correct? So the question says, what is the predicted value of this student's exam score? And then what is the residual? Explain the slope. Okay, please write down the question and answer all the A, B, C. You should be able to do that. We don't have time. Fast. I want to cover as much as I can, okay? Please be fast. Oh, you're thinking about this one?
Yeah, I'm thinking about that equation.
Yeah, that's why I was cleaning the board, so I had to keep it here for the next question. Yeah, you're not using it. Exactly, that's a good point. So there is a difference between this question and the next one. In this question, you already have the slope in the line, correct? You see the slope. And next question, you don't have the slope, you have to calculate that. But the question, when you see the line like that, means you already have the slope, you don't have to calculate the slope, right? Solve the first question, and if you are done, just start writing down the next question. Okay? So when you are finding residual, observed y will be 87, right? Minus the predicted y, minus the predicted y, which you get from the previous step. So in the first equation, y hat equals 46.2 plus 2.71. You just replace it. Exactly. And then what you get? 27. That way you will get what you have, which is predicted y, right? And then observed y goes here, the predicted y you got goes here, right? Then it goes to the residual. It's easy, huh? Shall I solve it? No? Did you write down the definition of a slope? I don't see that. Definition. Interpret the slope. So what you should write down? For 1 unit increase in explanatory variable, now in a self-explanatory variable, you should write down the variable you have. What is that? Study time, right? For 1 unit increase in a study time, the predicted exam score will increase or decrease? increase because the slope is positive, correct? Increase how many units? B units is 2.71, right? Okay, so let's do this. It says we have equation y hat equal 46.2 plus 2.71x, and we already know this is a slope, we already know this is a, right? It says there is one student in this class studies for 16 hours and the observed response, right? Observed response is 87 points. Correct? Then it says what is the predicted value of this student's exam score. Y hat is the predicted exam score or predicted response, right? So y hat is equal to 46.2 plus 2.71. What we should write down instead of x? 16. So calculate this plus what? Huh?
43.6.
36. Good. And then what is the predicted response? Huh? 89.56 points. So a student's exam score should be 89.56, but obviously it was just 87. Yeah, it's not good. Should be about above 90. So this one is almost 90. If you round it. Okay. Do you understand this? That is the response observed value, but this is the predicted value. The line predicted this score for that person. So now, let me write down. This is the predicted response. Exam score, right? So what the next question says, find the residual. E is equal to observed y minus predicted y, right? What was the observed y? 87 minus the predicted y is, so the difference is negative 2.56. This is the residual or error. So if we had a scatter plot, the point for this individual would be below the line, right? You don't have to, you don't have to write this down for me. The question is just asking to find residual. It didn't ask you to explain anything, but just for your understanding, how this residual can help us maybe. Okay? Do you understand this? This is clear? So now the next question says, explain the slope of this least square regression line. What it tells us regard to the explanatory and response variable. And what is the value of a slope? We already talked about this. The value of a slope is obvious from the line, right? 2.71, which is a positive number. And then, the way we interpret the slope now. We said for 1 unit increase in explanatory variable, and now you should think, what was the explanatory variable in this study? Study time. So what should I write down for 1 unit increase in study time, the
Exam score.
predicted exam score, increase or decrease? Increases. How many units? 2.71 units. So now you know if you study 1 more hour, your exam score maybe increases 2.71. 2.71 points. Okay? If you study 2 more hours, you have almost 5 credit added to your exam. 3 hours, just multiply. Then you can study that much. Right? Do you have any question? So now please write down the second question. And I expect you to solve the second question using these formulas you have on the board. Okay, the first step again is to recognizing and understanding the explanatory variable and response variable, correct? And then as soon as you know which variable is explanatory variable, which variable is response variable, whatever you have in front of them, like let's say this one is x, for example, correct? And whatever you have in front of that belongs to x variable, right? X bar, like a standard deviation of x. Do you understand what I say? So you can easily find a standard deviation for x, a standard deviation for y, x bar, y bar. Replace all of them in this formula. And then already you have this correlation 0.86, correct? So try your best. So this one will have to get on the other one. We'll have a different temperature. See? Temperature will have effect on. Okay, so what is your guess for a response variable? Okay, let's read that. It says to model the relationship between peak outside temperature and number of emergency calls it receives in corresponding 7-hour period, an emergency service measures this variable once a week for several months in part A through C. Use the summary statistic below to find the equation of this square regression line for, here is important, predicting the number of emergency calls from the peak temperature outside. Is that giving you any clue which variable is response? Predicting the response from explanatory variable, right? So what is response now? Response is the emergency call, correct? So if temperature outside increases, they have more emergency call, correct? Temperature decreases, they have less emergency call. So what is your opinion about the direction of relation? Direction of relation. What is that here? Direction could be either positive or negative, right? So one variable is increasing, another also increases. One variable decreases, another will decrease. So what is the direction? Positive, correct? So the correlation should be positive. That's why you see 0.86 positive number, right? So now you know what is response variable. Response variable is the emergency call, and the explanatory variable is the peak temperature outside. So now you should know what is S of y, S of x, x bar, y bar, and then find the slope, find the intercept, okay? So if you chose a wrong one, all your answer would be different, right? Did you find it? Shall I solve it? Or you're solving? Yeah, you try.
exercise sacrifice.
Am I right? Correct?
Yes.
So whatever we have in front of the emergency call belongs to Y, right? Whatever we have in front of this one belongs to X. So I should tell you, please always use your knowledge to recognize what variable is X, what variable is Y. Just because the first row here was Y, it's not always like that. I can easily switch this. Correct? So use your knowledge to recognize what variable is exact, because it happens in the exam. I see some students just choose the first row because in class I solved questions and the first row was Y. They thought, okay, always the first row is Y. But it's not like that. We talked about this. We should find the response variable, explanatory variable using like explanatory effects on Y, explanatory cause change on Y, correct? Y is predicted by X. X is predicting Y. We use these 4 sentences to find which variable is Y, which variable is X, right? So now, as soon as we know, we can write down a slope is equal to R multiply SY divided by SX. The slope is, correlation is 0.86, SY is 2.9, 11.7, the slope is 2.213. This one. So let's just keep. Okay, so slope is positive, correct? So the direction of a scatter plot we talked about, one increase, another increases, the direction was positive, the slope is positive, correlation is positive. Do you see the relation between correlation and the slope? Both are positive. If a slope has any sign, correlation will have the same sign. If correlation has any sign, slope will have the same sign. So these both have the same sign. So a slope here says if. Slope says, interpreting a slope. It didn't ask you, but I'm going to interpret for you. It says, for 1 unit increase in what? One unit increase in explanatory variable. Which one is explanatory variable? 1 unit increase in peak temperature outside. The number of emergency calls will increase or decrease? Increase. How many units? 1 units. Correct? Means almost, if you think mathematically, almost for 4 unit temperature increase, we will have 1 emergency call. Almost 1 extra emergency call. Correct? Right? Because 0.21 multiply 5 temperature increasing temperature, we will have 1 emergency call. 5 multiply this gives us 1, correct? So that's why. So now B says A is equal to Y bar minus B X bar 8.5 minus 0.21 multiplies to 86.4. Be careful, sometimes the slope is negative. Sometimes the slope is negative and the sign between these two is negative. Imagine negative multiply negative becomes positive. Be careful about this. Okay? So now the slope is positive, so it's easy. So what is the answer here? Intercept is 9.64. Okay? C write equation for least square regression line. Equation for least square regression line is, right? So what should I replace here? 21 multiplied to x plus, which becomes minus 1. So y hat is equal to 0.21 x minus 9.64. Okay? Do you have any questions so far? So now the next question says, calculate r squared. So you see that it says r power 2, right? R was 0.86 power 2, or multiply to itself, and we get r squared. And r squared is coefficient of determination. So let's talk about r squared now. ABC r squared 0.86 power 2. Can you calculate this for me?
0.74.
0.78 7396.
That one is,
It's already 0.74.
it's 7396. I think they put 0.74 because 2 decimal places.
Okay, so let's put 74, right?
Yeah.
You round it, okay? So we call this coefficient of determination. So whenever we have the correlation, we can find coefficient of determination. So now what coefficient of determination tells us? So first of all, when you want to find coefficient of determination, you know you are using correlation power to get this number. Change this number, convert this number to the percentage. So how many percent? 74%, right? Then this coefficient of determination tells us how good is your regression line. This is square regression line. How good is that? Means how much information this least square regression line is giving you. How much information it gives you. Okay? So if I want to write down a kind of complete formal interpretation, I will write down 74% fraction of variation of response variable explained by this least square regression line we found. Explained by this, explained by this square regression line, on the other variable, which is explanatory variable. So if we know this definition, we can here write down number of emergency call, because we know this emergency call is response variable, correct? Explained by the least square regression line on the explanatory variable, which is peak temperature outside. So generally, it just gives you information about the least square regression line and how strong it can predict everything or how good it is. So 74% is not that bad. It could, some least square regression line are really perfect, they explain almost 90-95% of everything and gives us enough information. This is not bad, but imagine if it was like 20-25%, obviously it was not that good information from the line. So maybe we needed another better least square regression line to be able to, you know, predict everything perfectly. So, do you have any question now? The last thing I want to talk about is the relation between a slope and correlation. I still have more things to talk about. I want to talk about the relation between correlation and a slope. Okay. Formula for a slope is r sy divided by sx, right? A standard deviation, if you remember, I said, is always a positive number because it's under square root, right? We take a square root of whatever number, and a square root, we know that numbers under square root should be positive, correct? So square root is a positive number. A standard deviation is always a positive number. So S of y is positive. S of x is positive. The fraction of two positive numbers is always positive, right? Correct? So, in this formula, this part is always positive, correct? So, if that one is positive, so what happens if our slope is, our correlation is a negative number? Negative multiplied positive becomes, so the slope is negative. What happens if our slope is, our correlation is positive? Positive multiplied positive is positive. So you see that if you have correlation, if you know what is the sign of correlation, you can easily say the sign of a slope is, for example, positive or negative. You cannot say exactly what is a slope until you have the rest of this formula, means the standard deviations, correct? You cannot calculate everything unless you have all the information, but at least you can say these two have the same sign. Correlation and a slope have the same sign, correct? So this is the relation between correlation and slope. Whatever sign correlation has, the slope will have the same sign. How many minutes we have? We have 2 more minutes. Wait, 2 more minutes. So influential, there are 3 definitions I want to talk about because you have your spring break and I want to finish chapter 5, so you are able to, work on chapter 4 and 5 during this break, okay? Just 3 definitions. Be patient, please. Maybe 5 more minutes after class. So, 1, influential observations. Influential observation is the outlier itself. What was outlier? Outlier was the observation which is outside of overall pattern, correct? So influential observation is an outlier which has a strong effect on correlation and least square regression line or least square regression line. So whenever the outlier has effect on either of these or both of these, we will call that outlier an influential observation. There are two errors which are possible in our study when we are calculating correlation, and we should always prevent this kind of errors. One is ecological correlation, another is extrapolation. Ecological correlation. You can listen to me and just read the notes later because we have this in PDF. Okay, ecological correlation. Whenever I have my student in this class and I want to see what's the effect of physical activity on their weight loss, okay? So I find the physical activity, data for physical activity. I find data for weight loss, and I will find a correlation between these two, correct? So I have 25, 30 individuals and find information for each variable and compare these two variables, find a correlation for them. Versus a time that I have 5, 6 classes, I find the value for physical activity, I find the value for weight loss for each class, and then find average of physical activity for this 5 class, average of weight loss for this 5 class, and then now I will find correlation for average of these two variables. So the first one, I had some individual comparing two variables. The second one, I had many individual and find average and find the correlation of average. This second one is not good because you cannot get the correct answer, because this is the difference between average of variables versus the just individual variable. So when you are finding average of variables, the information maybe is not perfect and correct. You are kind of ignoring some of errors in the study. So this situation is ecological correlation, which cause a problem if you find the average of variable rather than individual kind of variable. Another thing that we should prevent is extrapolation. Whenever, for example, I am calculating the relation between people's age and their height, because we know up to certain age people are growing and they get taller and then it stops, and even when people get older their bones will shrink, correct? Is that correct? So if I have a least square regression line of, for example, individual from age 4 to 19 and find the least square regression of the relation between their height and their age, everything is perfect as long as my individuals are between this age, and whatever value I get, I can predict the specific height for a certain age between 5 to 18, correct? And my least square regression line will work perfectly. But all of a sudden, if someone tells me, okay, now please predict the height for a person who is 50 years old. I say, okay, if I put this 50 years in my least square regression line, definitely I will get a really huge height and the person would be so tall. Why? Because the person they offered me is outside of the overall range of my explanatory variable. The range of age was from 5 to 18, correct? So whenever you choose an individual outside of the range of explanatory variable, probably the result will not be correct. So you should always be careful choosing individuals inside the range of explanatory variables you have, otherwise the information predicted response will be wrong, and that causes extrapolation. Do you have any question? So you have this definition in our PDF for chapter 5. You are done with chapter 5. You are able to start and work on your assignment. You have all the break for those students who had a kind of weakness in chapter 3. This is the best time to work on chapter 3, because later we will go back to that chapter 3 and you will forget everything, and that would be horrible. You cannot, review or recall anything. So use the spring break to work on chapter 3 and understand the Z table and normal